actually a point I was about to make. So we had 6 of these boilers. This is one boiler, believe it or not. It's 11 foot in diameter and 21 foot long boiler that would have been used to produce the 160 pounds per square inch steam that I was talking about. So what you have is what basically is called a double-ended Scotch fire tube boiler. Fire tube boilers by this time period were actually outdated. They were going on what's called water tube boilers, but we could go on forever about that too. So I'm going to describe how this really worked in a way, or at least how they operated it. So in this space, you didn't have very many petty officers like in the engineering space. This is where you would start out as an engineer. And it's not because it was particularly unskilled, this was a skilled job as well, so they were still paid more than the deck force. But you had these guys called firemen. That nowadays a fireman is someone who puts out fires. Back then a fireman typically was relating to, at least in the Navy, was relating to putting fires in a boiler. So a fireman was the stoker. Nowadays in civilian terms they're called stokers, but in the Navy they call them firemen. So you had firemen first class and second class. It was just a specialty thing at that point. If you're first class, you're probably one of the better guys. If you're second class, you're paid a little less because you didn't do as much stoking as the first class guys. So what you'd have is 2 guys in here for stoking, 2 firemen. You have one guy here, and then you're responsible for 2 furnaces each. So you also have a weird little firing order, 1, 2, 3, 4, and that was kind of a rhythmic thing. You'd actually trade off with your partner in here. And so you would have a line of coal, that I'll explain how it got there. But you have a line of coal here, you would shovel it in, starting with 1. You get, about a minute later, you'd be done, at casual speeds at least. You'd be done, you'd look over to this guy who would start stoking 2, and then you trade back to 3 and 4. And that just helps you not get off, that makes you remember, which one you just pulled, it makes you take a break in a way so you don't overdo it. And by being in a rhythm, you don't really have to think as much about what's going on. You do have to think quite a bit though. These are very particular. You have to make sure there's no gaps. Everything was perfectly even with no mushrooming on the sides or anything like that. And it had to be about 2 inches thick, or very precisely in the 1890s they wanted you to make it about 2 or 3 inches thick of coal. And saying that, it sounds kind of strange because you're used to coal being these big chunks that, it's kind of hard to get it level. So we have that's called anthracite. And you didn't really use that in ships in this time period. You use what's called bituminous coal, which is a lot thinner grounds basically. It's a different make as well, but basically the way to look at it is it's a lot thinner. It's more like powder. So you can actually put this big thick layer of it in coal bunkers or in the furnaces. Now, coal bunkers, which we had 40 of, are what you store your coal in a ship like this. So they're called coal bunkers, and we could carry 1,000 tons of coal in our 40 coal bunkers, which is quite a bit of coal. Usually it sounds like we would like to have more like 800 tons, which is still a lot, but that would be all kept in here. Not all of it in this one. There's 40 of them, remember, but this is what's called a primary bunker. This one carried about 50 tons of that coal, and this is what directly fed the boiler. So this is called a primary coal bunker. About 5 or 6 others would be feeding into this one, coal bunkers. And the way they would feed coal is by hand. You'd use a shovel like that one, or maybe a hoe or anything like that, or you just carry a bag with coal in wheelbarrows or whatever. And you have all these guys called coal passers that were in charge of this. They were the lowest in the engineering force scale. They were the lowest paid, they were guys that didn't know much about engineering but wanted to be engineers. They didn't pass any tests or anything. So they'd be thrown in there, and there's not much lighting, and it was a pretty miserable job. You see these guys pretty dirty all the time. They get black lung over time if you don't progress fast enough. And so they were called coal passers. Now you had about 2 in here in the primary, and then you have 1 guy in here who basically he's a fireman in training. They would switch out these guys that work out in the fire room so they could watch the firemen work, so they could eventually make 18 tons of coal an hour. So that's a lot of coal. You can't sustain that for very long. So these guys would have to be working non-stop. Actually, you'd have to stoke each of these in less than 26 seconds. So you'd have to get that 20 pounds in there in about 26 seconds before the next guy moves to his. And at that point, you're doing it simultaneously because you need to keep that volume of steam up. And you need to keep these burning as fast as possible because they're going to get cooled down very rapidly by all the incoming water for that speed. So it could get very busy in here. Now at the same time, you're also producing about 5 tons of ash, because of course coal, as you burn it, produces ash, and so at 18 tons of coal an hour, you produce about 5 tons of ash an hour. And that would be brought out by the coal passers typically, or coal passer, through these, you can see these handles here. These are actually sliding doors that slide all the way out to about here. That's why this is caved in here, so you actually have room for it. And so you pull it all the way out, and then you would take the ash out and put it in this closet. There would be a bucket in here that would carry about 300 pounds of ash. And so you'd have a bucket in there, and when it's full, you have the deck force hoist up on it with a steam hoist called an ash hoist. And you would pull it all the way up to the berth deck, or the upper deck, and then they dump it overboard. So while going full steam, you're putting 5 tons of ash in the water an hour. So you can imagine the big gray streaks these types of ships would make as they're going through the water at full steam. So pretty dirty ship. Of course this space is very dirty. Now there's one little myth that I'd like to address here once in a while, which is, you expect the fire rooms to be the worst places in the entire ship. Now in the case of Olympia, there's plenty of records of the engine room being the worst place in the ship because of its heat and humidity, and this place being the best place to be in engineering. That's because we had forced updraft. Now forced updraft, well, mandatory forced updraft, was this giant fan system that was steam powered. It would suck out all the air in here and replace it non-stop. That was to not only provide air to the combustion chambers, but also to pull out all the coal dust in the air, which they had deemed highly explosive, which it is in certain concentrations. And that way you have a constantly ventilated space. Now one of the problems they had with that is it actually could go the opposite direction, where if you're up in the Arctic, which the ship actually went, the ship went up to Russia quite a few times in the winter, they'd actually be pulling on whatever is right at those ventilators at the top deck. The ventilators are these big scoops that you'd see sometimes in the cartoons and things that people jump down or whatever. Usually you don't want to jump down them because you'll jump into a fan or something. But these big ones pull on all the air for these spaces, and whatever is in front of it, any cold air, snow, anything else sucked down in here. There's no filters or anything. So you can imagine going to Russia, if it's heavily snowing, you're blowing snow into the boiler rooms. So it's very cold in here when you're up in Russia. And in the Philippines, it's very hot in here, and it basically just reflects wherever you're at. So there are pictures of guys wearing pea coats in the boiler rooms because of how cold it is. And they weren't allowed to open these very much because, you would lose heat, and then you lose pressure and steam. So
How many hours would they be shoveling?
the engineering watch is 6 hours. So
They'd shovel for 6 hours.
they would trade off. There'd be a fireman on backup where they let a coal passer try it out, depending on how fast they're going and what the situation is. But it was pretty tough. Eventually switched over to the deck schedule, which is a 4-hour watch, which is a lot better. I think by World War I, it was a 4-hour watch. But yeah, originally.